Welcome to the lecture. Today we will discuss fast Fourier transform. So far we have discussed discrete time Fourier transform. What is the disadvantage of this technique DFT? The only disadvantage of this technique is the computational cost, because in this case there are a lot of computations. As we have this formula, we have seen this formula so far for DFT. So if we want to find the number of additions or how many computations of addition are to be performed in this case, it will come out to be this one. Because for when k is equal to 0, obviously n minus 1 additions. So when we have n is equal to k is equal to n, so for that we have n into n plus 1, n minus 1 additions, and multiplications for a single frequency sample we have n multiplications. So for n sample we will have n into n multiplications. So for computers it is very difficult to perform so much computations, and it will be very slow process, and it will take time, it will consume time, it will be very costly. For example, if we have n is equal to 1000 and we have the processing speed of 1 megahertz, it will then zero point 0.1 millisecond processing, it will take 0.1 millisecond to compute the whole process. And if we have n is equal to 1 million, and we have 1 megahertz of processor, then it will take 1 million seconds to perform the operations, because n square by the processing speed (1 million into 1 million over 1 million), it will come to be 1 million second, which is very huge. So to minimize this, we have another technique which is widely used, is fast Fourier transform. In this we reduce the number of computations. So how these computations are reduced will be discussed in this lecture. For fast Fourier transform, first we suppose this equal to W of nk. After that it looks like a simple formula, because when we see this, it is very complex. It seems to be complex because the human brain, when look like huge numbers or a complex number, it feels that it is complex thing, and we just convert it into simple one. Now after that we divide the signal into two parts. One is even and the other one is odd. As We have discussed in the previous lectures signal decomposition techniques. So this is even odd decomposition. First of all, let me tell you what is this W of n. Again, the concept of circle comes into play. If we have n is equal to 4, then we divide this circle into 4 parts. If we have n is equal to 8, we divide this circle into 8 parts, and so on. If we have n is equal to 16, we divide this circle into 16 equal parts. So what is W of n? Here n is equal to 4, just write 4 here, and this is 0 4 4 0, and then move just clockwise. This is 4 1, this is 4 2, and this is W 4 3. Similarly, in this case, 8 0, W 8 1, W 8 2, W 8 3, W 8 4, W 8 5, W 8 6, W 8 7. So by seeing these two circles, what conclusion is made? As you can see, when W of n 0, the value is 1 at every time whenever W of n 0 comes, it is equal to 1. On the other side, when W of n into n by 2 comes, the value is always minus 1, as I have written here. And you can see there are a lot of conjugates. This one will be the conjugate of this one, and similarly this one will be the conjugate of this one. I have written all these things. Now move on to the decomposition, even odd decomposition. For even decomposition, we substitute n is equal to 2r, because you can see that whatever r is, when we multiply it with 2, it will be the even one, because multiples of 2 are even numbers. But for odd case, we add 1. Whenever we add 1 into 2r, it will become an odd number. For example, I have n is equal to r is equal to 2. So from here it comes 4. But when I substitute this into this one, it will come out to be 5, which is an odd number. So just substitute n is equal to 2r in this part and n is equal to 2r plus 1 in this part. What will be the result? It will move n is equal to r is equal to 0, 2r, w of r, w of 2r, k of 2r. Now similarly in this case, Now if we see that this is even part, and if we see this one, you can see that we have W of 2R K 2R plus K, which will be equal to W of 2R K 2R dot W of N K, which is 2R into K. Here, sorry, it is N here. I have written. So we can write this in this form. So if we substitute this into the above formula, it will come out to be, let's suppose this is even part, and plus the constant, which is this one, into the whole factor excluding W of K. Just write W of Nk here, and this is odd part. So this is the end result of this one, fast Fourier transform. So let have an example. I have the similar example that I discussed in the last lecture, similar sequence, which is x of n is equal to 1 minus 2 3 1 2 minus 1 2 1. So if I apply, I said that divide this sequence into two parts, even odd. So the amplitudes that I marked are even amplitudes. As you can see that 0, 1, 2, 3, 4, 5, 6, 7. So 6, 4, 2, 0 are even amplitudes. I've written here 1, 3, 2, 2, as you can see 2, 2, 1, 3, 1. The even for even. So now I want to calculate E of 0. What I will do, I'll just apply the 4-point DFT. Just apply 4-point DFT. K is equal to 0. Just add all these values. 4, 4, 8. Similarly for the next one, apply 4-point DFT. X of 1. What is x of 1? 1. K is equal to 1, but n is equal to 0 first time. It is 1 because E0 is 1 plus 3 into 1, 2, it comes out to be 4, and e power minus j is minus j. So plus, the next one is 2, it comes out to be minus 1 plus 2 into, substitute in this formula, it will be j, because for this case k is equal to 3, n is equal to 1, k is equal to 1, n is equal to 3, capital N is equal to 4, so 6 by 4, it will be the 90 degree, I think 3 by 2, so 3 by 2, it will be again this one, so it is plus 2j. What will be the answer? 1 minus 3j minus 2 plus 2j. The final answer will be minus 1 minus j. As I've written all the answers, just calculate in this way. Similarly, for odd, apply this formula as well. So what we get from this one? Are these values equal to the previous one that we have obtained in the last lecture? Obviously not, because you can see that 8 minus 1 were different. First one is 7, the next one is a complex number, but here is minus 1. So how we can write this these values into this form? Again, if I want to write x of 0, e of 0 plus o of 0, that is odd of 0, w of 4 and 8, because we have 8 samples and k is equal to 0. So what is e of 0? E of 0 is 8 plus minus 1, o of 0 is minus 1, and 8 0 is 1, so you can see that it comes out to be 7. So similarly, you can find all these values, these will be equal to this one. So what we conclude from this whole discussion is that how we can reduce our computations, our computational cost. As you can see that this is n by 2, so multiplication will be n by 2 into n by 2. It will be reduced to n square by 4. Here we have n square, and in this case we have number of multiplications n square by 4. It is divided by 4. It is 4 times less than the previous one. Similarly, in case of addition, we have this number of additions. So as you can see that additions are also reduced. So if we divide further these points into 2-point DFT, it will also reduce more computational cost, and it is more efficient than DFT, and it is widely used in today's uh, computers, PCs, laptop for computation and to find a signal in time domain to frequency domain, or to convert a signal that is in time domain to frequency domain. That's it for today's lecture. Thanks very much.